Assalamu alaikum wa rahmatullah. I welcome you all to the 16th and possibly the last video on the first material. In this video, we will explain power. Power is defined as the time rate of doing work or the time rate of energy transfer. This means we are quantifying the amount of energy used in 1 second or the amount of energy converted from one form to another in 1 second. The formula is power denoted by P equals work done or energy expended divided by time taken. And this means energy or work per second. And in a work is denoted by W and then the time is denoted by T in lowercase. But we also know that work is force times distance in the direction of force. So we can say instead of W, we can write F times S divided by T. Then this is displacement. Displacement because distance in the direction of force means displacement. So the displacement here divided by time is velocity. So we can say force times velocity. It means we have at least two units to calculate, two formula to calculate power. Either we say power is work done or energy expended divided by time, or we say work done equals force times velocity, depending on what we are given in a problem. The SI unit of power is the watt, denoted by capital W, which is the rate of transfer of energy of 1 joule per second. Okay, if you look at the formula here, from the formula, since work is measured in joule and time is measured in second, you have joule divided by second. This means the unit of power should be joule per second. But instead of that, we are using watt, and the watt is equivalent to the joule per second. This is why they say 1 watt equals 1 joule per second. But we have larger units of power such as kilowatt and megawatt. 1 kilowatt is 1000 watt and 1 megawatt is 1 million watt. In the industry, they also have another unit of power they call horsepower. 1 horsepower is 746 watt, and when you divide this by 1000, it will be 0.745 approximated to 0.75 kilowatt. The power, or let me say the energy, there is a unit of energy that is sometimes used for electrical energy, and that is the kilowatt hour. The kilowatt hour. Kilowatt comes from power, hour comes from time. If you go back to the formula here, the unit of power is kilowatt. The unit of time, and you give instead of second you use hour. So kilowatt times hour will be kilowatt hour, and this is equal to the energy that you have here. Okay, so it means that energy can also be expressed in kilowatt hour, and electrical energies are usually expressed in kilowatt hour. Okay, this is the energy used by an appliance with a power of 1 kilowatt in 1 hour. Meaning, if I have an electrical appliance that has a power of 1 kilowatt and then I use it for 1 hour, then it means the energy will be power times time. The 1 kilowatt power times the 1 hour time will give me 1 kilowatt hour. And then if I change this to joule, I will have 1 kilowatt hour. 1 kilowatt is 1000, and then the hour here, 1 hour is 60 times 60, which is 3600 seconds. If I multiply this, I will get 3.6 times 10 to the power 6, which is 3.6 megawatts. Okay. Example 3.11, calculate the power of a pump which lifts 500 kilograms of water through a vertical height of 4 meters in 5 seconds, assuming G equals 10 meters per second squared. Okay, here power is mgh over T. This is because we know power is work done over time, and the work done here, since it is lifting, work done is mgh, is work done against gravity, and our m is 50. You see the 50, our g multiplied by the height 4 divided by the time in second 5 seconds. So when you substitute, you will get 4,000. You divide by 1,000. This will be 4 kilowatt power. The second example says a car traveling at a speed of 20 meters per second overcomes a constant frictional resistance of 300 Newton. What is the horsepower of the engine? And they say we should take 1 horsepower as 3 over 4 kilowatt. Okay, engine power. Remember, power is work done over time, but if you are not given the work done and time, you are given force and velocity, you can multiply the two to get the power. And in this problem, we are given the force, we are given the velocity, so we multiply the force given by the velocity, we get 6,000, we divide by 1,000, it becomes 6 kilowatts. Now we have to express this kilowatt in horsepower, because they say what is the horsepower. So, and in bracket we are told 1 horsepower is 3 over 4 kilowatt. So we want to know 1 kilowatt is what? You multiply both sides by 4 over 3, so that 4 over 3 will be cancelled here and it will appear here. So 1 kilowatt will be 4 over 3 uh, uh, horsepower. This fraction appears here, the reciprocal of it, 4 over 3. And now this 4 over 3, multiply it by 6. 4 times 6 will be 24, and then 24 divided by 3 will give us 8. Okay, give us 8. So the engine power is 8 horsepower in horsepower. Finally, force distance graph. The significance of the force distance graph is that we can get the work done or the energy used using the graph. The vertical axis is for the force, the horizontal axis is for the distance, and it always depends on the shape of the graph. If the shape of the graph is a rectangle, then the area of the rectangle will give us the work done or energy used. If it is a triangle, now the area of this triangle shaded will give us the work done or the energy used. And this is why they say work done equals energy stored in spring and is equal to area of triangle using this triangle. So this will be half FD, okay, because it's a triangle. If it is this one, they will just say FD because it's length times breadth without the half. Wow, so this is a quick summary of what we learned, and then we have exercise here. Exercise 3, a boy of mass 60 kilogram runs up a set of steps of total height 3 meters. What is the work done in joules? Well, work done is mgh, mass times g10 times height 3. Okay, and I think you will get something like 1800 here. Okay, and then number 2, the speed of a bullet of mass this is this. What is its kinetic energy in joules? Well, divide this by 1000 to get 0.04 because it's not in the SI unit. Multiply this by 1000 and divide it by 60 times 60, which is 3600. I think you will get 60, then half mass squared, the velocity squared. This will be around 72. It's like we solve a problem like this. Number 4, which of the following statement is not correct? Elastic PE is half kx squared. This is a correct formula. Power is force times velocity. This is also correct. Gravitational potential energy is half gh. No, this is incorrect. Unit of power is watt. This is correct, but C is not correct. 4. What is the engine power of a car with retarding force 500 Newton moving at speed as constant speed 20 meter? Well, force times velocity, look at it here. Power equals force times velocity. So 500 times 200 will give you 10,000. I think 2 times 5, 10. 10,000. You divide by 1,000, it will be 10 in kilowatts. So your answer is A. The rest are all objective questions. So essay type questions. So I leave them with you to practice. Assalamu alaikum wa rahmatullah.